everybody, welcome to a short video on right triangle trig. The textbook's a bit light on this topic, so I wanted to make you guys a video. So, let's talk about the trig ratios. So there are three trigonometric ratios. There's sine, cosine, and tangent. So sine has an abbreviation of sin, and it's pronounced sine, not sin. Cosine is abbreviated with a cos, and tangent is abbreviated tan. And what they are is just a comparison of two quantities in a right triangle, okay? So if you have a right triangle, the sine ratio, so the sine of any angle is equal to the ratio of the opposite side to the hypotenuse. So it's opposite over hypotenuse is equal to the side of an angle. Okay? And I have a little triangle down here, and I've labeled all the sides for you. So we've got angle A, and side A is across from it. Angle B, and side B is across from it. Angle C is the right angle, and then the side C is the hypotenuse of that right triangle. So if I want to do the sine of angle A, just for example, here's angle A. The sine for angle A would equal its opposite side. So I'm just looking right across from the angle, right here. The opposite side is the little a, over the hypotenuse, and the hypotenuse is always across from the right angle. And it's always the longest side of a right triangle. So the hypotenuse for this triangle is the little c. Okay? Next up, cosine. So sine is opposite over hypotenuse. Cosine of any angle is adjacent over hypotenuse. So it's the ratio of the adjacent side to the hypotenuse in a right triangle. And so in our little triangle down here for angle A, we've got cosine of angle A would equal its adjacent side. So there's two sides that are next to angle A. The C and B are both next to it, but C is also the hypotenuse because it's across from the right angle. So the adjacent side would be this one, would be B, angle, or side B. It's really like from that angle to the right angle, that side right here. So B is the adjacent side, and C is still the hypotenuse. Last one is tangent. And so tangent of any angle is opposite over adjacent. So it's the ratio of the opposite side to the adjacent side in a right triangle. So if I want to find the tangent of A in my right triangle down here, the opposite side is across from it, it's little a. And the adjacent side is the side next to it that's not the hypotenuse. So the side next to it is the little b. Okay? So that's what they are. Personally, I like to write my SOHCAHTOA like this. I like to do like S and the OH like this. So I remember that sine equals opposite over hypotenuse. Ka, like this. So cosine equals adjacent over hypotenuse. And TOA like that. Tangent equals opposite over adjacent. And that reminds me of where everything is. Alright, let's do some examples. Alright, so this is actually example 1. Use the triangle below to determine the sine, cosine, and tangent of angle A. Okay, well here's my angle A, and we're just going to find all three. So I'm going to do the sine of A, cosine of A, and tangent of A. Alright. So sine is opposite over hypotenuse, so the opposite side would be 22 meters over hypotenuse, which is 27.9 meters. And you can use your calculator to get an approximation here. So if I do 22 divided by 27.9, I get approximately, I'm going to use a little wavy equal sign for approximate. So approximately 0.7885. All right. Cosine of A. Well, cosine is adjacent over hypotenuse. The adjacent side would be the one next to it. It's 17.2 meters. And the hypotenuse is still the one across from the right angle, which is 27.9 meters. Okay, so if I do 17.2 divided by 27.9, it's approximately 0.61648. So that 8's going to make it round up. So 6165. Last up is tangent of A. So tangent is opposite over adjacent. The opposite side is 22 meters. And the adjacent side is right next to it. It's 17.2 meters. And if I do 22 divided by 17.2, I get about 1.279. And then there's a 0.6, so round up, so about 9.1. Okay, so there's my nice little trig ratios. Next up, we are going to be finding unknown side lengths and unknown angles. So find the unknown side lengths in the triangle below. And apparently the right angle didn't print out. There we go. And neither did the angle measurement. So, let's see, I had this at 65 degrees. Let's put that in. Okay, so I've got a right triangle. This angle is 65 degrees, and the adjacent side is 15.8. I'm going to try to find the opposite side, and I'm going to try to find the hypotenuse. So let's just do one at a time. A comes before C in the alphabet, so let's start there. If I want to find A, side length A, that is opposite of the 65 degrees, and I have the adjacent side already. So if I look at my trig ratios, my TOA, and I think, well, which one has opposite and adjacent in it? That would be tangent. So tangent 65 degrees equals my opposite, which is the little a that I'm solving for, over adjacent, which is the one next to it, the 15.8. And I would like to get a by itself so I can actually solve for it. So to do that, the opposite of division is multiplication, so I'll multiply both sides by 15.8. So 15.8 times the tangent of 65 degrees equals little a. And I can actually type that exactly like that into my calculator. You do need to make sure that you are in degree mode, however that is for your calculator. Personally, I have a little TI-30X, and this little DRG will change me from radians to degrees if it, okay? So, and also I can see the little DEG at the bottom to see that I'm in degrees. So for me, I'm going to go ahead and type that in. I'm going to have 15.8 times the tangent of 65 degrees. And we'll see that that's about 33.88 or about 33.9 if you want to round it to the nearest tenth. Oops. 33.9. We were in meters. We stay in meters. Okay. If I want to solve for the side length C, that's the hypotenuse, and again we have the adjacent side. And so if I look at my ratios, which one has adjacent and hypotenuse? That would be this cosine ratio. So cosine of 65 degrees equals adjacent, which is 15.8, over the hypotenuse, which is the little c here. Well, if I multiply both sides by 15.8, that doesn't really help me at all. It's divided by c, so if I want to undo this fraction on both sides, I'm going to multiply both sides by c, which cancels this out. And then the c over here, to get it by itself, I'll divide both sides by the cosine of 65 degrees. So c would be 15.8 divided by the cosine of 65 degrees. That's what that setup would look like. And again, I'm just typing that in right into my calculator. I clear this. I do 15.8 divided by the cosine of 65 degrees. And that hypotenuse is about 37.4 meters. Okay. And so that's how you solve for side lengths. Alright, next up, solving for angles. Okay, so I have another triangle for you, and here's my right angle. I've got two side lengths listed. I have the hypotenuse here. I know it's the hypotenuse because it's across from the right angle. And then I have this bottom side here. It's adjacent to angle A. It's across. It's opposite from angle B. Okay? And I'd like to find the unknown angles, so I want to find A and I want to find B. So how about we go in alphabetical order again? We'll find A first. So if I want to find angle A, the side lengths that I have a side length that's adjacent to it, and I have a side length that's the hypotenuse. So if I'm looking back up here at which one has adjacent and hypotenuse in it, that's the cosine ratio. So the cosine of angle A equals adjacent, which is 17.4, over hypotenuse, which is 21.3. And then you're like, well, how do I get rid of that cosine? You can't just divide by cosine because it's not multiplication. We need to undo that operation. So the opposite operation of a cosine is the inverse cosine. So if I take the cosine inverse of both sides, like that, what's going to happen is the cosine inverse and cosine will cancel out. That's the actual opposite operation. And then you'll just be left with angle A equals the inverse cosine of 17.4 over 21.3. And your calculator will have an inverse cosine button somewhere. For my calculator, it's right above the cosine, so I have to press second and then cosine to get there. So second cosine gives me that inverse that I'm looking for. So I'm going to do the inverse cosine of 17.4 divided by 21.3, like that. Close my parentheses off and press enter. And it's about 35.2 degrees. Okay, let's do the other one. For angle B, I have the opposite side and the hypotenuse. So if I'm looking at my ratios again, which one has the opposite and the hypotenuse? Well, that's the sine ratio. So that's the one I'm going to use. So the sine of angle B equals opposite, which is 17.4, over hypotenuse, which is 21.3. And we're going to do the same thing. We're going to take the sine inverse of both sides, so that angle B equals the sine inverse of 17.4 over 21.3. Okay? And again, I'll use my calculator. So my sine inverse is above my sine, so I press second and then sine to get the sine inverse function. So I'm doing sine inverse of 17.4 over 21.3, just like that, and press enter. And that angle is about 54.77, so about 54.8 degrees. And if you ever need to just double check yourself, to see if that all makes sense, all three angles should add up to 180 degrees. Okay? Next, I'll do the next video on some applications, so tune in to the next video.